So we have already talked about perpendicular bisectors, the unique properties that come with perpendicular bisectors, and what we call the perpendicular bisector theorem. Namely, that the perpendicular bisector is the set of all points equidistant from the endpoints of a segment. Now, angle bisectors also have unique properties as it relates to the angles, and something that we would call the angle bisector equidistance theorem. And we call it the equidistance theorem because there is another angle bisector theorem that is coming up in a later module. But first, a quick review of the definition of an angle bisector, which is that an angle bisector splits an angle into two equal halves. And so, if the angle bisector for this particular angle were overlaid in blue, it would mean that the two halves of the angle that the bisector creates would be congruent, which they are in this diagram. And so, when we looked at the perpendicular bisector, we took a look at the distance from a point to the endpoints of a segment. Well, in angle bisector, we can also choose an arbitrary points on the bisector and talk about the distance from that point to each of the edges of the angle. And that distance from that point to the sides of the angle is not zero, like the angle bisector that intersects it, because that point is not on one of those lines. So if we drew perpendicular lines, or perpendicular segments, from the point to each of the edges of the angle there, we could talk about the distance from that point to those edges. And much like perpendicular bisectors that have an equidistance component to them, so do angle bisectors. And the angle bisector equidistance theorem says that if a point is on the angle bisector of an angle, it is equidistant from the edges of that angle. Or in other words, if we have angle ABC and ray AM, so that angle BAM is congruent to angle CAM, and BM and MC are perpendicular to AB and AC, then BM and CM are congruent. So go ahead, pause the video, copy down pretty much everything you see on the screen right now, come back when you're ready to move on. If while you're doing that, you want to take some time and strategize how we're going to prove that BM and CM are congruent, you can see a lot of the pieces are already there, then go ahead and do that. See if you can write the proof yourself. Come back when you're ready to see the actual proof and move on to the converse of the theorem. So, what we have in the given, as we're looking at our statements and reasons, is that BAM is congruent to CAM. I'm not going to recopy it there for the sake of space, but we have the given, so this is part of the given. What we are also given is that BM is perpendicular to AB, and CM is perpendicular to AC. Those are also pieces of the given because that is part of the construction of this triangle. Now, once we have that, we are actually almost there. It does not take a lot to show that BM and MC are congruent. In fact, by drawing the diagram like we have, we've split angle ABC into two right triangles, ABM and ACM. So once we know that that's true, we have two angles that we know are congruent. We have two right angles that we know are congruent. And so we just need a segment that's congruent, and it just so happens that AM is congruent to AM by the reflexive property. It's a shared side between those two triangles. So now we have two right triangles where a single segment and two angles that do not include the segment are congruent to those of another triangle. So we can say the triangle BAM is congruent to triangle CAM. And that is all because of angle, side. Once we have that, of course, then BM is congruent to CM because of CP, CTC, corresponding parts of congruent triangles are congruent. So if you haven't already, go ahead, pause the video and make sure this is copied down. If you have, we're going to move on to now the converse of the angle bisector equidistance theorem, which is that if a point is equidistant from the edges of a triangle, then it lies on the perpendicular bisector. Or, in other words, if we're going to put it into given and proof, if we know that BM is congruent to CM with all of the constraints that are there, including the 90-degree angle, then we know that BAM is congruent to CAM. You may even see a way to start the proof based on what we did before with the angle bisector theorem. So go ahead, pause the video, copy down everything that you see on the screen right now, and see what you can do about creating a proof for the converse of the angle bisector equidistance theorem. When you come back after pausing the video, we'll go through the proof. We'll see the complete statement of the angle bisector equidistance theorem in the same way that we saw for the perpendicular bisector theorem, and then we'll wrap up the video. So, again, as far as statements and reasons are concerned, in this case, other than the diagram that we have here, all we have to say is that BM is congruent to CM for our given. And for being complete, we add that BM is perpendicular to AB and that CM is perpendicular to AC. Those are noted in the diagram, but if we're being complete, they would be a part of the given. Well, much like the last proof with the angle bisector equidistance theorem, we are almost at what we need. We have a right angle, we have a leg, which means we have a lot of flexibility in terms of what we find out in terms of another congruent part. And the one that we know is that the hypotenuse of one right triangle is congruent to the hypotenuse of another right triangle by the reflexive property, which means that using hypotenuse leg, triangle BAM is congruent to triangle CAM, leading us to what we wanted in the first place, which is that angle BAM is congruent to angle CAM by CPCTC. If you haven't copied down this proof, go ahead, pause the video and do that now. Otherwise, we're going to move on to the last slide for the complete statement of the angle bisector equidistance theorem. And much like we had before, where we could put the perpendicular bisector theorem into one statement, the complete angle bisector equidistance theorem says that the angle bisector is the set of all points on the interior of an angle that are equidistant from the rays that form the edges of the angle. So go ahead, pause the video because you're about to lose the slide because the video is going to end, copy down this statement, and then it's time to wrap the video up.